All right, this is SAT Prep. We're doing test 3, section 4, and this is number 27. A rectangle was altered by increasing its length by 10% and decreasing its width by p%. If these alterations decrease the area of the rectangle by 12%, what is the value of p? All right, so let's look at two different situations here. Let's look at our original, right? So the original rectangle has an area that is length times width, right? The new rectangle, right? The new rectangle has, so we'll do area original, right? And we'll do area new, okay? The length of the new rectangle is increased by 10%, meaning you can either do 1.1 or you can recognize that it's 110 over 100, like because increase of 10%, right? If you increase by 10%, that means you take 100% and you add another 10%, okay? So that's 1.1 times the length, right? And then we know that the width was decreased by p%. Well, if you're decreased by p%, right, then essentially what that means is that you are retaining 100 minus p%, right? So like decreased by p% means that what you're keeping is 100 minus p over the 100 times the width, right? And what I know is I know that this new area is a 12% decrease in area. So I know that this is 0.88, right, of the original area. So this is actually enough information for me to find p. It's just going to be a little bit ugly, but we can make it happen. So I have this 110 over 100 times L, and I have this 100 minus p over 100 times W, right? And then I know that it's equal to this thing, which for the record is length times width. So if we put this together, and again, this is a pretty difficult setup, but if we put this together, I know that, sorry, that was a 0.88, it got erased. 0.88 times the length times the width, because that's the 0.88 of this, is equal to, and I could do it as 1.1 L if I want, right? And then unfortunately there's no way to clean up right now this 100 minus p over 100. We can deal with that in a sec, times W. So here's the crazy thing. It looks disgusting, but it's actually not so bad, because if I divide by L and W on both sides, they're just going to cancel, because that's all multiplication. So I get 0.88 equals 1.1 times this ugly, crazy monstrosity. Well, if I want to solve for p, I'd probably do it by starting by dividing by the 1.1, right? So 0.88 divided by 1.1, and I get that this is a 0.8, right? And essentially, one way to think about this, right, is that essentially this is 80%, right? So what we're looking at here is if we're keeping 80%, now you could solve this the other way, but if we're recognizing that this is about keeping 80%, then that means p is 20%. Another way to look at it is you could multiply the 100 over, you'd get 80 equals 100 minus p, you'd subtract the 100, and you'd get that p is 20. So that's how you land at p being 20%, right? We can go back up and pick 20, which is C. There are certainly other ways to get there. But what's a little bit tricky, so one way to get there, if this is like absolutely awful and you hate it, they don't, you could pick a length and a width, right? And you could see what happens if you modify the length and the width by a certain percent. So another way to do this problem, I guess, if you were trying to figure this out another way, right? So another way, if you're really hating this idea of using such abstract quantities, is you could just choose an easy length, which I'm going to pick 100 because that's super easy, and I'm going to choose an easy width, which I'm also going to call 100. So that would mean that the original area would be 100 times 100, right, or a 1 with 4 zeros, right? So that would be the original area, okay? Based on the modifications that they gave me, right, the new area, which I know is 88% of the old area, so we can deal with that in a sec, right? So the new area is, I increased the length by 10%. Well, that would be 110 because, again, I lazily picked this is my new length, right? I picked that. And I decreased the width by p%, right? Which essentially is going to mean that what I do is I multiply this by 100 minus p. So this is going to be my new width is going to be 100 minus p, because I would be multiplying the width, which we just said is 100, times the 100 minus p over 100, and so I just get 100 minus p. So what I end up getting is essentially that this, if we do 0.88 times 100, and 2 more zeros, so we're going to get this, right? And then we can solve the same way we solved before. So you could, again, it's a little bit helpful to pick a really easy, when I'm reducing things by percentages and I'm not told what to pick for length and width, it's easier to pick them to be 100 or some multiple of 100 so that percentages are easy. And I get to the same spot. Again, I get to p is 20. So that's another way to get there.